Welcome back to our Python Quickstart tutorial. Today's topic is on file I/O, which deals with reading from files and writing to files. File handling lends itself naturally to the topic of exception handling. We've seen a little bit of exception handling already when we either raised a type error or if we try to perform an operation that's not supported by a data type or something. So Python has a way to raise exceptions to tell us something goes wrong. But so far, whenever something went wrong, our code basically crashed. And that's not the elegant way of saying, oh, the normal end of my code is a crash. That's not how it should happen. There are things that can go wrong that can be anticipated. And if we can anticipate, we should actually handle them properly. So let's think of working with a file. We try to read a file, we try to open it, and the file doesn't exist. Or if you're on a Unix system, you don't have permission. Or on a Windows system, that file is already used by another application. You can't do it. Or you try to write and your hard disk is full. So the computer cannot write, it's gonna cause an exception. The elegant way is to at least do a graceful exit. Tell the user what's going on. Or tell the user, hey, I couldn't find the file. Can you point me to a different one? And keep going. So that elegant way of handling something that did not go the way as planned is called exception handling. Python has a very elegant way of dealing with that, and that's a construct that we call try except. So let's look at this in a simple example. We say we try to open a file that I call some unknown file. And I name it something because I know it doesn't exist on my disk. But I try to read it. So what would happen? If I have only this code, and let's try this, I just add an extra line. If we execute this, we got an error. Yeah, file not found error. That was not good. So, but we don't want our program to die like this. Instead, we want to run our code and say, hey, try to open. If the file exists, then we do something. Yeah, beautiful. Then we keep going. But if the file doesn't exist, we may want to say, can we open it for writing? Can we ask the user for a different name? Whatever. So when I look at this was, I got here file not found error. I could use the file not found error to check. There is a more generic, if you check the manual, file not found is a subclass of I/O error, any input-output error. And what we can do is we take one or more statements. So how do we do more statements? Everything that's in a block here is the same indentation after the try statement. We say try that set of commands. If those work, this command's done and the code keeps going. If an exception occurs, we can say except, and then we ask for the exception. I/O error. If that exception happens, we can have an alternative code. In this case, I just say, hey, print file could not be opened for reading. Fine, and then it keeps going. If I want to crash it, fine. But in this case, I just say, let the user know and gracefully continue. And if another error, anything other than an I/O error happened, then that's my default, except if none, I could have multiple here. If none of the anticipated errors happened, then I know I have no clue, but it's definitely not good. And I say, you know what, crash. Now we want to end it. Let's try this. Hey, we try this. I showed you up here, this course is an error. It went into this exception and nicely said print file could not be opened for reading. Just to show you that there could be different issues, what if I do this with a different error? It wasn't a type error, it was an IO error. Then it fell into the accept and it crashes and say it was a file not found error. If I have more than one error options here, so we say, hey, type error, that wasn't what we had, but we could have this, and I want to try IO error as a generic error. So file not found error should be the file could not be found. So let's run this. If it is a file not found error, we say it couldn't be found. If it's another error in this, it could be IO error, then it says could not be opened for reading, we don't know better. And if it's neither of those, we crash. So we can try this. And it said file could not be found. So the subclass was controlling it. It picked it up here. It didn't go in the IO error. It was more specific. And that error type, it is, I found that here from the original error message, and then I can handle things in a nicer fashion. You should always have some sort of error handling around any type of file action. You may need it more. Careful when you think about the try and accept feature. It is slowing your code down. It is bad strategy to cover up errors with try and accept. Unless you know why things could go wrong, that this is a runtime scenario, you should not use try and accept. If your code crashes and you try to use try and accept to cover up your programming bugs, that's a very bad strategy. So use it rarely, but typically around file IO, you want to use it.